Hi guys, today we'll be looking at section 3I, exponential equations. So take a look at the learning intelligence. To know the form of an exponential equation, to be able to rewrite an expression using its lowest base, and to be able to solve simple exponential equations using a common base. Exponential equations contain a polynomial within the index or indices of the terms in the equation. To solve for the unknown in exponential equations, we use our knowledge of indices and surds and try to equate powers where possible. We know that 2 to the power of 2 is equal to 4, and 2 to the power of 3 is 8, but 2 to the power of what number is 5? That is, if we write as an equation, 2 to the power of x is equal to 5, and we're solving for x. Use the calculator and try the error to estimate the value of x when 2 to the power of x is equal to 5 by completing this table. So we've got this table, and we know 2 to the power of 2 is 4. That's not enough. That's too small complement to get 5. And if once you get into 3, 2 to the power of 3, that's 8. And that's too big. In other words, this x has to be between 2 and 3. That's because our number 5 is between 4 and 8. Okay, therefore, what you could do is just keep trying. You try 2.5, which is a good try. That's halfway between 2 and 3. You get 5.65. That's too big. And then you can try 2.1. Put it in your calculator and keep going, and you can get a more and more precise value. Continue trying your values until you find answer correct to 3 decimal places. Okay, a simple exponential equation is of the form a to the power of x is equal to b, where both a and b has to be greater than 0, and a cannot be equal to 1. Okay, the thing is, if a is not greater than 0, let's say a is less than 0, have a look, -3 to the power of x, that's going to be problematic. For example, if your x is equal to 1, -3 to the power of 1 is going to be -3. But if x is equal to -1, it becomes -3 to the power of -1, which you got to flip it because you have negative indices. 1 over -3. Okay, so that's -1/3. All right. So here we've got some problem. It's just the graph wouldn't. We can't graph this because it's getting random values. Let me show you in decimals, and you're gonna see what this means. So for example, this one, let's say -3 to the power of x, and you're gonna see this graph, okay? And that's not a graph we're interested in because it's just it's too many dots. So it's not exponential. Remember, exponential is only one part, okay? All right, so be careful to remember that exponential equation has to satisfy both a and b that are greater than 0. Otherwise, you will get a weird graph before, and that's not exponential, okay? There's only one solution to exponential equation of this form. Many exponential equations can be solved by expressing both sides of the equation using the same base. That is, a to the power of x is equal to a to the power of y, and we can equate the indices. So x has to be equal to y. Example 1, solve for x in each of the following. 3 to the power of x is equal to 27. So the strategy here is just to make them have the same base. All right. So 3 to the power of x, we can keep it, but 27, we know that's 3 to the power of 3. Okay. So that's from your experience, 3 to the power of 3. If you don't have this such number sense, you can just guess a trial. Okay. Try the error. So once you get here, we know we can equate the indices. X has to be equal to 3. And that's done for this one. We've solved for x. Next one, 2 to the power of x is equal to 1 out of 8. So to do this, again, I can stay, 2 to the power of x can stay here, but this 1 over 8, what I can do is I can make it as 1 over 2 to the power of 3, okay? Because I know 2 to the power of 3 is equal to 8, and I want you to remember that 2 to the power of 3 is equal to 8, and 3 to the power of 3 is equal to 27. Those are commonly found, and also 4 to the power of 3 would be 64, okay? These ones, I want you to remember them. Remember, because they are so commonly used. Okay, so commonly used, remember. Okay, now once you get here, they are not having the same base, but what can I do to make them have the same base? I'm gonna flip this number. So this becomes 2 to the power of negative 3, okay? So I can flip it by changing these positive indices to negative, and then they have the same indices, and x is equal to negative 3. Next one, 16x is equal to 64. This one is a bit different because we're going to change both sides. From the facts I've told you, 4 cubed is equal to 64. So let's change it to 4 cubed on the right-hand side. At this side, it's 16x. And we know 4 squared is equal to 16. So let's put a bracket just in case you get confused. So that's 16 to the power of x. And 16, that's 4 squared to the power of x is equal to 4 cubed. And by applying index law, retain the base, multiply the indices. 4 2x is equal to 4 to the power of 3. And then we can equate the power. 2x is equal to 3 gives us x is equal to 1.5. Okay. Great. Now, you might be wondering why we can't just make it a 16 something, because 16, even 16 squared, 64, you don't really, 16 to the power of 2 will give you 256, which is so much larger than 64. So we have to change it to 4. All right. But to be honest, if you've seen this question once, you'll be fine in the future because you realize that we're going to use 4 instead of just 16. Okay, this one, like you've seen 3 and 27, you would realize I can just change it, okay? 3 to the power of 2x minus 1, and 27, that's 3 to the power of 3, bracket x. All right, so 3 to the power of 2x minus 1 equals to 3 to the, what is that? Oh, that's x, 3 to the 3x. And then we equate power, 2x minus 1 is equal to 3x. Solve this equation. To solve this equation, I can take away 2x for both sides. So negative 1, 3x take away 2x is just 1x. Therefore, x is equal to negative 1. Okay. Therefore, x is equal to negative 1. Last example, very similar to the previous question. 5 to the 3x minus 1 is equal to 5 squared bracket x, because 25 means 5 squared. And then we do 5 to the 3x minus 1 is equal to 5 to the 2x. So we've got the same base now. And we can just equate indices. 3x minus 1 is equal to 2x. Take away 2x for both sides. This side's got 3x minus 2x, 1x, and minus 1. And this side is got 0 because 2x take away 2x is 0. So x is equal to 1. Okay, so I move this to the right. It's 1. All right, that's the end of my part. Hope you enjoy. And now it's your time to complete your question for exercise 3i. Don't forget, you've still got some video to supplementary videos here to watch. Okay, thank you.